this very short video, what we're going to do is just have a quick look at some of the key definitions that we need to know for this section of work. So we've got three key terms: atomic number, mass number and isotopes, and they are just in the order that they're written up there. So we'll just write in those words and then we'll have a look at each one and what it means. So our first term, atomic number, is the number of protons in the nucleus of an atom. So where are we going to find this term, this atomic number? If we were to look on our periodic table, what we'll be able to do is see where we can find atomic number. So here is a copy of the periodic table, and if we were to look at our periodic table, we can see we've got a key here, and at the bottom it says that underneath the symbol you will find the atomic number or proton number for the elements. And what you can notice about the periodic table is that the elements are arranged in order of atomic number. So hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7. So this bottom number on the periodic table is the proton number or the atomic number. It tells you which element it is. If the atomic number is 7, the element is nitrogen. It cannot be anything else other than nitrogen. When you have 7 protons, you are nitrogen. Okay, so the atomic number is the identifier of the element. Our second term, mass number, it's actually not found on the periodic table. The number on the periodic table is something called the relative atomic mass, which is an average of all the isotopes. So you will not find mass number on the periodic table. You will have to be given it in the question, and it's the number of protons plus neutrons in the nucleus. So it's given that the protons and the neutrons are the things with relative mass of 1, it's everything with a significant mass, and it's all located in the nucleus. So the mass number tells you the total number of protons and neutrons. And then our last one is isotopes. So isotopes, plural, are two things or more, two or more things, atoms, plural, of the same element. Now if they're the same element, they will have the same number of protons, because everything that has 7 protons is nitrogen, everything that has 6 is carbon, but they do have different numbers, different neutrons, different number of neutrons, so that mass number at the top will be different. So our last little thing to think about is to do with these isotopes. Why do isotopes have the same chemical properties? Well, that is because chemical properties are determined by electrons. Chemistry is all about the movement of electrons. So chemical properties are determined by the number of electrons, and it's not all the electrons, it's the electrons in that outer shell that are going to be lost or gained in our reactions. Now if isotopes have the same number of protons, they will have the same number of outer shell electrons. So we need to just write a little extra thing there, and this is our key answer. Isotopes have the same number of outer shell electrons. Valence shell, they're sometimes called, the outer shell, the valence shell. And that is why same number of outer shell electrons. That is why they have the same chemical properties. So that's just some key terms that we're going to be using in this next section.